depth about the science. If there are any high school students who want to read a scientific paper, they may want to take that home. Okay, so this is how the molecular hydrogen cooled the gas. Okay, this is, in the upper left corner is a hydrogen molecule. It's two hydrogen atoms stuck together, not with Velcro, but with electrostatic forces. And it's cold because it's not vibrating, it's not rotating. And then there's a hydrogen atom. Whoops, I'm getting ahead of myself. There's a hydrogen atom, and it's hot. It's moving fast. That's thermal energy. Eventually, the atom will hit the molecule. Oh, it missed. It's going to hit the molecule, and it's going to lose energy. And when it does, it cools down. It moves more slowly. That energy goes into the molecule, which then radiates that heat, that energy, out of the cloud. This is the catalytic process by which the molecular hydrogen cooled the primordial clouds, enabling the formation of the first stars. So, how did the hydrogen form? Okay, hydrogen has a proton in the nucleus. It's three quarks bound together. The charge is +1. And orbiting the nucleus is an electron, which has a charge of -1. So the total charge of the system is 0. And we represent this with capital H for hydrogen. This hydrogen atom associates with another hydrogen atom. Actually, that reminds me of a bad joke. I promise you guys really good science and really bad jokes. Two hydrogen atoms are walking down the street, and they bump into one another. And one of them says, "Oh my God, I lost my electron." And the second one says, "Are you certain?" And the first one says, "Yes, I'm positive." You know, it could be good jokes and bad science, okay? Okay, this second hydrogen atom is actually a little bit different because it has an extra electron. So the total charge is -1. So the H associates with H-, forming molecular hydrogen. It's two protons, two electrons, and the third electron detaches. It flies off. So this chemical reaction is called associative detachment. I live in New York City. A lot of my friends are therapists. They tell me if one of their patients had this condition, they would probably prescribe some of the primordial lithium. This is not a condition in DSM-5. This is fundamental chemistry. It's also chemistry. It's not nuclear fusion because the nuclei remain distinct. They haven't fused together. And I'll talk about nuclear fusion later in the talk. So I want to give you a sense of what some of the data that we use look like. This is a plot of for this reaction. This is how fast the reaction goes. And this is a function of temperature. And room temperature is about 300 Kelvin, right about here. And there are three circles with error bars. And those circles are laboratory measurements. As a matter of fact, the one on the far right is the most recent measurement before we did our work. And naively, you'd look at that and you'd say, oh, these calculations, everything else on this plot is a theoretical calculation. You'd naively say, oh, these calculations, they must be right and these must be wrong. But I should point out that these are the newest calculations. So theory and experiment have not or had not converged to the same value. Quantum mechanics was discovered in 1925. This plot comes from 2005. 90 years later, I hope I did the math right, 80 years later. 80 years later, they still hadn't been able to calculate this properly or this most fundamental reaction. So we decided, well, all right, let's try to study it. And let me describe the experiment by which we simulate the chemistry that led to the formation of the first star. So what do we have here? We have a black screen. We have a gas discharge, which basically is just a gas that we put an electrical current through and we create H-. and we make a beam of H minus. So here's our beam of H minus. Now we have to convert some of the H minus into atomic hydrogen, neutral atomic hydrogen. So we get a really high-powered laser, and we went to these guys. Who are you going to call? So we fire our laser across the H minus beam, and we rip off the extra electron in about 10% of the cases, converting about 10% of the H minus into atomic hydrogen. And now what we do is we measure the H2 that's formed. So let me show a picture of the laboratory. This is the apparatus the day after we got first signal. And you can tell because there's smiley balloons here. So